Hey everybody, hope you're all having a great day so far. Let's go ahead and get started. Hope you all had a great weekend too. Yeah, Monday. Alright. Yeah, my weekend was pretty nice, relaxing. Didn't really do much game development, so I'm ready to get back into the swing of things. So we're still working on trying to make a nice terrain mesh for our Tactical Lizard Tamer game, which again is a kind of a mix between Pokemon battles if they took place on a Fire Emblem map. And though it still doesn't look like much, but it's better than what we had before, which was kind of just like Minecraft style little hexagons. Now we have a nice mesh. Oh, this is kind of weird. That's a strange artifact. It looks like this is curved down. It probably has something to do with the normals, since these are like... I guess Unity doesn't know to just have these normals stick straight up. I won't worry about it too much right now. But it's kind of weird. It looks like it's curving down there. Anyway, that was, sorry, tangent. So right now we're working on mouse picking, which basically wherever the mouse is we want to be able to tell what tile it's over, and we got it working for the most part. See if we can actually tell these monsters to move, and if we click here it will register, whereas if we just click some random place it knows that that's not a valid position and then they move to the correct spot. So one thing we haven't done yet though is if we look at the collision mesh itself, which let me get rid of the visible mesh. So the collision mesh here, we still haven't done these faces. We only did a couple sides. Also, is it still debugging when we're over something? Okay, yeah, it does. So if I go over, and we can see our raycast line over in the editor. When it's black, it's going through, so nothing's picked right now because we're on a side that we didn't generate the collision for. I guess that one's not either. This one should be, so when I move over here it says block 12. So that's right. So we want to, of course, get those other sides working. Okay, so it's been the weekend, so I've slept 3 times since last stream. So I gotta get my bearings where I was. Okay, so I think how I was gonna do it, I guess I should bring back up my nice little image. Let me get that back. It's a very wonderful diagram I drew in Paint that just tells me the numbers for how the hexagon neighbors fit together. Let me see. So I want to edit. Okay. So again, this is our hexagon, and it's the column and the row, and then you can see the neighbors here. I think how I set up is that, so right now the hexagon that we're generating right now is responsible for building the cliff face to its left, I think, because it has to have a column greater than 0. So yeah, and that's, yeah, so this one. So I think, and that's because we know that we generate from bottom up and then left to right, so we know this one will always be created before us. So we can share the vertices that way. So again, since we know bottom up, we can also, when we get to our hexagon, we can go ahead and generate the southwest and southeast sides. So we'll go ahead and do that. So this one exists, yeah, just if we're at a row greater than 0. So it's pretty simple. Probably should add some comments here. Generate western cliff face. And then we'll generate a southwestern cliff face. Okay. And this index is one row down, so we need to subtract the row size, which I think we get from the blueprint. Good. Okay, so we only want to generate this cliff face, obviously, if the elevations are different. So we'll need to get the data for our neighbor, which we'll basically just use to get the numbers of the vertices so that we can share them. And but again, these numbers will change. I think this code will stay the same. We're kind of duplicating a lot. I don't really know. There might be a better way that we can like extract this out into a common function. Because really the only thing that we're going to change are these numbers, I think. So yeah, what would it be? So we'll need to pass it, I guess, our index. And then these numbers here, so 542 and then 521. Neighbor vert CA and oops, I keep forgetting to type the type. Okay, so let's copy this code. Oh yeah, this, well, I remember I should need to change that from column greater than 0 to row greater than 0. Okay, so we already have that. And we also need to get our blueprint cell. Okay, what's this block index? Oh, okay, so we can figure this out ourselves. So the block index, what makes it different than just the cell index is a cell is kind of like a stack of blocks because the terrain only has one cell for every row and height, or row and column. It doesn't care about the layer. Whereas in the game code, there's basically a bunch of blocks stacked on top of each other, so layers do matter. So when we convert from the cell index to the block index, we need to take the elevation into account. Which is basically what this does. And the reason we need to know that is because okay, this is a little bit oh, I see. Okay, so the reason we need to know this is because we need to store that information for the mouse picking algorithm to be able to tell which block a specific face belongs to, or more specifically a triangle belongs to. But I actually can do it like this. So if the neighbor is higher elevation than us, then this neighbor will actually own the cell. But if it's a lower elevation, then we'll actually own the cell. And for right now, we're just taking into account just one layer difference. If there's two layer differences, then of course we need to break these cliff faces up. Which I should probably put a little note here so I will remember to do that. So multi-layer cliff faces. Okay, so yeah, we don't need this at all. Yeah, so I need to get my own storage. Which I'll just use my index to index that array. Pretty simple. Okay, so what this does, it adds a triangle. Well, I'll just use the western cliff, for example. So it goes from this point, 5, 4, 2, which if you're looking from outside, you gotta try and imagine that your camera's here looking towards the cliff, and then this winding needs to be clockwise. That's just how Unity displays meshes. So we've got to go 5, 4, 2, and then 5, 2, 1. Now that I think about it, the winding would actually be different if this block is higher than us, because the camera would actually be outside here. Okay, yeah, so this needs to be moved like this. But I guess also I should switch these around, so I guess the question is, I guess this should be vertex A. I guess we might as well have them in order. So my vert A will be 4. And then, excuse me, neighbor vertex A would be 1, and B would be 2. Okay, so now that I got that, let's go ahead and replace this code. Make cliff, and it's index, and then index -1, and then 4, 5, 1, 2. Okay, so now we need to take care of the case when the neighbor is actually higher than us. So now the camera would be out here looking this way. So to be clockwise, it would be 1, 2, 4 and 1, 2, 5. Right, I think, yeah. Although no, it's 1, 2, 4 and then 1, 4, 5. Okay. So we want to go with the neighbors first, and then 1 is A. And then let's see, so 4, which is my A. Oops, wrong window. Now I think about it, it might not ever be, like I might not need to actually pass these two, because the neighbor ones is always just on the opposite side, isn't it? That makes sense. So 5, yeah, because it's always just the one that's touching on the other side. So technically, I think we could figure that out using math, but okay. So anyway, so 1, 2, 4 and 1, 4, 5. Okay, so yeah, before we test that, I guess let's go ahead and make these other 2 cliff faces. Now that I think about it, for the collision mesh, I don't know if the clockwise winding really matters as much. Actually, it probably would matter if we ever need to use the normal, which is a vector pointing outwards from the collider, because that is also defined by the winding of the triangles. So I'll leave this how it is just in case we ever do need it. But anyway, this would be one row below, so it's index minus blueprint row size, and it's 3, 4, and 0, 1. Okay, and then the last one is the southeast cliff face, and that is column +1 and row -1, so it'd be just +1, and of course this only exists if this music's kind of loud, if the row is greater than 1 and we're not on the very last column right here. Column less than, I guess, well, the number of columns is obviously the row size. Sorry, if you can hear my dog, she must be playing. Okay, so yeah, I'm just looking over this code. I think it's all going to work. Okay, so I guess let's test it out. So what I really want to do is see if the collisions around here works. And basically if I move the mouse along these faces, okay, it goes to none, so something is wrong there. I was going to say the logs here should stay on block 12. Although it's not. So let's take a look. Oh yeah, the faces are all messed up, huh? So what is this really weird one? Let's look. Can I get it? So it looks like the problem cliff. This canvas always gets in the way. So it looks like this one is working, so that's southwest, and southeast is the broken one. I bet I just gave it the wrong vertices. Let's look. Oh yeah, I didn't change them. Okay. Because it needs to be 2, 3, and 5, 0. I think that should fix the problem with the weird vertices anyway, or those weird triangles I should say. Oops, I actually wanted to get rid of the canvas. Okay, so now, okay, so that's funny. That we form the triangles kind of different than the visible mesh, but oh, interesting. So it's only some of them that are formed differently, but it doesn't really matter because I think they can still be clockwise wound up. I guess now let's see if the mouse will give me the right block. So this should stay 12 as I move the mouse over it. And it would change down here, like when I just did that, but 12. Okay, so something is wrong on this side. Yeah, because you can look here and it's the the raycast is actually going through this middle hexagon to this part right here. I wonder if the winding does matter. I wouldn't be surprised. I probably could have gotten it wrong. Oops. So let's see. Does it do that? Yeah, so it's all these faces that are like matching up with the display. Except this one? Oh no, it goes through that too. So I guess probably I wound the vertices wrong. So now just to make sure, let's see which one that is. I'm just going to comment that side out, and I can see which ones form, and I'll know if the ones I commented are the messed up triangles or the working triangles. Okay, so the ones I commented are the working triangles, looks like. Yeah, because it just goes through those. Okay, so oops, didn't mean to double comment. So I guess I figured the winding wrong here. So let's look at this side. Alright, it should go 1, 2. Oh wait, so if I'm facing here, yeah, 1, 2, 4, that's counterclockwise. Okay, so I need to go 1, 5, 4, and 1, 4, 2. Okay, so this is vert B, and then vert A, and then 1. So 1, 5, 4, and then 1, 4, 2. So are these equivalent actually? So A, oh well no, they're actually, well no, it goes A, B, okay, so no, they are different. I was gonna say, maybe now I don't need to have like 2 possibilities for these triangles because they're equivalent, but if you look here, this order, neighbor A, my B, my A is not copied anywhere, so. I guess that also could be because the triangles are don't match up, but okay, so now they all, oh no, these still match up exactly with the display mesh, but let's see if the raycasting works now, because that's what really matters. And it does. It's always saying 12 on all sides. Okay. I don't really like, now I'm kind of bothered how these are different, so I think I might try and fix it. So really I just gotta flip the top. Yeah, so here it should be, yeah, so I can do A, B, 1, and then, or 4, 5, 1, and 4, 1, 2. Is that still clockwise though? Yeah, it's 4, 5, 1. Yeah, that's clockwise. Or is it? No, that's counterclockwise. So if I want to have the triangles, I basically want to have the diagonal going from 1 to 4 instead of 5 to 2. So if I want that to be clockwise, I should do 1, 2... Oh wait, no, that's counterclockwise. It should be 4, 1, 2, and... Oh wait, no way. So 5, 4, 1 is clockwise. And then 4, 2, 1. Okay. 5, 4, 1 and 4, 2, 1. Right, so we have 5, 4, 1, 4, 2, 1. Okay, so let's see if that doesn't mess. Let's make sure that doesn't mess up everything now. That way, I guess it will be nice to have the visible and collision meshes matching as much as possible, even though it doesn't really matter that much. So 12, 12, 12, 12, 12, and 12. And then if I look here, all the lines match up. Okay, so that makes me feel better about it. Alright, so now let's change this a little bit so that we'll have 2 layers of dirt and then one layer, or one little pocket where it's air. So basically we'll be testing the opposite cliff generation. Okay, so something, a bulk prototype registered called air. I thought it just created one by default. Maybe it's empty. Okay, there we go. So yeah, now you can see we have a valley. And I'm trying to see what this other cross in there is. Oh, it's just the grid. Okay. Okay, so everything looks good here. We still have a nice shadow and crisp edges. Okay, so let's look. Okay, so this is apparently block 8. Okay, and the collision is working. Excuse me, fine. And then block 7 and 11, 13, 17, and 16. So I think everything is still fine, and the reason I know is because when I move my mouse over this edge right here, the block that the mouse is over doesn't change, which is how I want it to work. So it doesn't really make sense that this block below is 12 though, and this one is 7. Because the elevation, because this should be the block on the first layer. Let's see if I count this right. So 1, 2, 3, 4, or wait, sorry, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, this is 12, but I guess the ones above it should be 15. Yeah, this one definitely should not be block 8. It must not be taking the elevation into account or something. Yeah, right here it says that's block 0, and that should be block 15. Because it's up one layer. What is going on there? Did you take into account the elevation? Maybe the layer size is not set? Oh yeah, the layer size is not set. Okay. I'm surprised that didn't cause a problem somewhere. So that would go in the blueprint builder. Wait, yeah, how did that not cause an error? Because we gotta figure out the number of rows, and number of rows is 0 if the layer size is 0. Oh no, I guess it figures out the number of rows by the number of cells, which works too. Wait, so layer size is kind of redundant because that is the same thing because there's one cell. Or how do I say this? There's one cell for every column and row pair. Yeah, so the layer size is the same as the number of cells. Okay, so let's get rid of this. Oh, I don't want to get rid of it in the board though. It's supposed to be in the blueprint. Okay, I think that's it. Alright, so let's see if the block IDs match to how I expect them to. Alright, I just need to delete that line. Okay, so this should be block 12 still because it's on the bottom layer. So everything here should be somewhere between, when I keep saying 15, this is supposed to be 25 actually, because it's between 0 and 5 times 5 minus 1 technically. And then here, yeah, it's block 25. Okay, so this block is 41. Alright, so everything looks good now. Okay, so I think we are done with mouse picking. At least for now. It'll probably get more complicated. Well, we could do... oh wait, we need to do that. Sorry, my voice was giving out. We need to do the multi-layer clip faces and then maybe optimize the tops of the hexagons, because right now they use 6 triangles, which we definitely need for the visible mesh because this is going to get a lot more complicated, but for the collision mesh it's basically just going to stay flat, so we can actually optimize the tops of the hexagons to only use 4 triangles. Here, here, and there. So yeah, maybe we'll do that. But a more pressing issue is definitely the multiple layers. So how do I want to test this out? I guess let's just make a 3-layer map, and I'll go back to just having there be a flat layer there, and then we'll create a tall column in the middle. And yeah, we will want to test other configurations of this too. Like maybe if one of these neighbors was on the second layer, that could cause some issues. But let's just go with something simple for now. Alright, so the map generated fine, but if we look, so this top, this should be correct, it says 62, but it says that both of these are all 62, and really this bottom one should be, I don't know, 62 minus 25, which is 37? I think, I don't want to too much math in my head, but right now it's saying that this whole column is basically 1 block when that's not true, because it's actually 2 blocks high. So there should be another separation here, and then we'll need to create more triangles. And it won't really be that difficult, I don't think. Yeah, collision mesh. We'll need to do something like this as well for the visible mesh, but that's going to get a lot more complicated, so whenever we do, like you can see, better cliffs here, and that's when we'll tackle that. Okay, so yeah, the elevations are different. Then we'll need to basically loop through each different elevation. So let's see, for int e equals 0, e less. Okay, well now, how do I want to do this? Elevation difference is the absolute value between my elevation minus the neighbor elevation. Okay, so while e is less than the difference, so the storage, yeah, this is actually the same. Although, yeah, we'll need to, yeah, we'll have to create new vertices for all the middle. So I think how I should do this is we should separate this into like the top and bottom vertices. So we always start at the top. Okay, so looking here, on this side, we would want to have, let's see, how do we do that actually? So we actually has to go clockwise, so we did 5, 4, 2, but then we wanted to have a line to go 1 to 4, so we actually did 5, 4, 1, and then 4, 2, 1. You could also just do it 4, 2, 1, and 4, 1, 5, that works as well. And then, excuse me, on the other side, I guess we just need to flip it because we would do clockwise, we do 1, 5, 4, which is the same as 4, 2, 1 except flipped, and that's clockwise. And then we would do, okay, so here we wanted a line to go that way actually, so we do 1, 5, 2. No, that's not right. 5, 4, 1. I'm trying to see if there's a way that I can like arrange these numbers so that basically I'd have like a top A, a top B, and then a bottom A and bottom B. Let's try it out and see. So for every elevation, we'd have to get all these vertice indexes. Yeah, I'm just trying to think what the best way to do this would be. Because we probably don't want to like have to test this every time we go through the loop. Probably better actually if we like started at the bottom and and then set the bottom A and bottom B, and then as we went up every tile or every elevation, then we'd put the bottom ones on the, or put the top values into the bottom values, and then figure out the new top ones. So I guess this should actually go down. Or I guess only the bottom ones, because the bottom ones would be the only ones that stay in between the loop. Because every iteration of the loop we'd get new top vertices. Okay, so here the neighbor is greater. So I'm trying to think, if the neighbor is greater, then that's on this side. And, okay, so 1, 2, that's... So if the camera is facing this way, 4, 5 is counterclockwise from the camera's view because it's going to the right. So I guess the greater one needs to be first. On this side, did the same way. So clockwise is this way, so yeah, the greater one does come first as well. Okay, so that helps a little bit. So this would be neighbor storage, neighbor vert B. The corners are right in here. It's a little confusing that we flip between A and B here, but I'm just trying to go with keeping A and... Well, basically the A vertice goes first before the B in clockwise order from whatever direction you're looking at the face. And for these, we're looking down onto the vertice, which is why here they're in numerical order. But actually, with respect to the camera sitting in the center facing this cliff, the 5 is clockwise first before the 4. Okay, but then I actually did this backwards, because if the neighbor cell is above us, then the bottom is actually our vertice. So I think I'll just flip this, that way I can just, I'll have to copy that.